Okay, on to our next session. Please welcome Oliver Grawert, who's been a long time community member, has led the development of Ubuntu-based distros, and wants to give us an insight into the world of UbuntuCore, which is another development of Ubuntu itself for special purposes. Oh, we're having a little technical issue here, but okay. I'll let Oliver introduce himself and his work, and I'll let you take it away. So this is yours.
Thank you.
Well.
Yeah, so hi, I'm Ogra. I'm a snapaholic. And, well, I just changed my presentation and added this prefix picture because Mark mentioned the UDSs. And this was at one of the first UDSs, and you might recognize that long-haired hippie in the middle there, who just spoke to you before. And yeah, that's pretty much the spirit we had at the old UDSs. And I wish that we end up this week in a similar mood like this picture shows you. So let's get started. And oh, by the way, Dani is a real pillar of the Snapcraft community, and I want to shout out for her for doing that. You are a unicorn, to quote a dear colleague of mine. Yeah. So UbuntuCore. Who here remembers the Ubuntu phone? So when we turned down the phone, we had all this, oh, there's somebody with the phone in his hands. When we turned down the phone, we actually had all these concepts and all these technologies implemented where you have image-based updates, where you have confined packages. Back then we called them click packages. And well, we had to stop the phone simply because it wasn't sustainable commercially. But we didn't want to throw away what we had from the phone. And we started merging the technology into something new, which was snap packages, as you might know or not. And snap packages give you a very high level of security by simply having all your binary stuff in a single GPG signed squash of as file system image that never gets unpacked on your disk. So it's compressed, it stays there. That means we save a lot of space. That also means it's super tinker-proof. You can't really change it because, well, it's a read-only file system. There is metadata in it, in YAML files. There are different types of snap packages. Most of you will only, there's Mark, and he missed the picture. So there's four types of snap packages. You as end users might only get in touch with the apps, but there's others. So if you install your snap, you have it actually running on top of a runtime environment. That's the OS snap, which we call the core snap, or core 20 or core 22 nowadays. To build an image, you need more than that. Like, you want to boot, so you need a bootloader. You want to run your hardware, so you need a kernel. So this is where we come to the other types of snaps. Like the gadget snap is carrying your bootloader. It has some information about your partitioning. It has information about which connections between snaps should be established on a first start of the system. And then there's the kernel snap, which, well, obviously is a kernel. As you might know or not, snaps do support transactional upgrades and rollbacks. So you can go forward and backward in time, and can always use snap revert to go back to the last version of the snap on your disk. Now, this doesn't only work for application snaps. That means, imagine, I'm uploading a kernel snap with a really big bug in it. So your system actually panics on boot. Can you guess what happens? Yeah, Danny, you can. I know that. Well, what happens is the system recognizes your kernel panicked, and it will reboot back into the former kernel without you doing anything. So I can guarantee you that this IoT device or this cell tower device that sits in the woods where you would pay 10,000 euros to send somebody out to fix it will always be on. It will always be running, because every time something breaks, it will just automatically go back to the former version if it needs to. Now, this cell tower thing probably communicates through 3G or 4G, so you don't want to shovel a lot of data over that line when you upgrade. And snaps give you an easy way by simply doing binary diffs between two snap packages, and you only download that 5 lines that you changed. Snaps are available on a big plethora of distros. Then we do have frameworks that you can use to actually put your application on top and to develop your application in. Yeah, and you can see, I mean, this set of distros is really lacking the current state. We have a lot more distros nowadays. So as I said before, snaps are GPG signed or binary file system images, and are indeed read-only. When you run a snap, it's confined by certain bits of your kernel. There's not a lot of runtime stuff in the user space beyond the snap confine tool that wraps around every single executable in your snap. So all these kernel features like AppArmor, seccomp, namespaces are utilized by that tool directly from the kernel, so you don't need extra layers or anything that would slow down or yeah, take resources of your system. The confinement we have is, we call it root safe. So you can run stuff as root on your system without that application being able to gain root of your system. It only gains root on top of that core snap it runs on, which is also a read-only snap, so you don't really gain a lot. But it will never be able to be root on your desktop PC or on your server. To actually allow snaps to communicate with hardware, with the outside world, or with each other, we do have interfaces. They are defined by slots and plugs, so you can put a plug into a slot, like you put your laptop into the wall charger or something, to actually make snaps communicate to each other, access your camera, access your audio, and so on. So you need one of these plugs for anything you want to do. That makes it easy for us to allow you to do things without having to review your snaps when you upload them. So this is how an Ubuntu core system actually looks like. You have your gadget snap that defines the lower level, like bootloader and partitioning and so on. Then you have your 4.4 kernel sitting on top. Sorry for that kernel number. I didn't really recognize it was there. And on top of that, you have the core snap that I just explained to you is your root file system for running your snaps on the desktop. But in this case, it is actually the root file system of the system. It's not just your execution environment, but the core snap is your runtime to boot into. So we reuse it in that case to be a standard root file system. Now, if you upgrade a snap, it will keep the old data around. So it copies forward the old data, then installs the new snap, and you have 2 copies of your snap on the disk, which means when you call snap revert, you roll back to the former version that was on disk. Your snaps have to be self-contained. So if you build something on Qt or Flutter, you should either ship your Qt or Flutter inside your snap, because, well, the snap will not see the outside world. Or you could create a content snap that actually shares its content with other snaps. We have an interface for that. This is what Flutter does, for example, or the KDE Neon snaps do for Qt, or the GNOME snaps do for GTK applications. And indeed, snaps can be independently updated by whatever you want. You can update the kernel separately from the core, update the application separately from kernel and core. So yeah, I've already mentioned the different types of snaps. We don't need to go into much detail here. As I said before, your core snap is the execution environment for everything on desktop installs. And well, on UbuntuCore, it's the actual rootfs. It's not really containing a lot. It's mostly to just run snapd and systemd to actually boot your system, and everything else should come from a snap that snapd then uses from the install. There are some special interfaces, like the camera interface, for example, that only the core snap provides you. So to access your camera, your snap needs to define the camera plug. Then somebody needs to plug in that plug when you actually run your application. You can do that through the gadget snap or through the store by asking in the forum for getting auto connections for that. And the security team will actually review if that's okay, and then grant or deny you to actually have an auto connection here. Snaps also come with a built-in configuration interface, so you can run snapget or snapset to set configuration options of your application. The application indeed needs to gather that from the system. So you need to write a little shell script or Python script or C application that actually does something with that data you get from the snapget or snapset commands. Snaps also, which isn't listed here, but snaps also have a built-in backup. So you can always back up your data from your application, even for that special version that's just running in there. If you upgrade to the next version, you can still go back to the former version and use your backup with that version if you want to. So the kernel snap actually needs a minimal set of AppArmor changes that are still not upstream, but we are getting there. So somewhere within the 6.0 timeframe or 6.x timeframe, I hope we will eventually come to a point where you can just use a plain upstream kernel. Currently, you still need 2 patches on top of that. The whole boot mechanism of the snaps of UbuntuCore lives in the initRD. Up to Core 18, Ubuntu Core 18, we used the old mechanism from the distro and just reused that. With Core 20, you actually have systemd in the initRD. Everything was redesigned. I don't know if Dimitri is still here. I think he has a talk about kernels this week. He actually put in a lot of work to make that happen, to actually switch over from the old script-based initRD stuff to having a modern systemd-based initRD. So your kernel can be actually any kernel as long as you have this patch set on top. Like if you buy, UbuntuCore often runs on weird hardware you wouldn't buy off the shelf somewhere, but there's a special device with a special kernel made by a special company, and they don't really give that out. So you do have a BSP. Well, they will give it to you if you are a customer, but not to everybody. So, but you usually get a tarball or whatever with that board where you have the kernel source inside with all the patches this board specifically needs. This is called a BSP, board support package. And you can actually easily package these kernels as snaps with our wonderful kernel plugin in Snapcraft. That makes it really, really easy. And indeed, as I said before, even that BSP kernel will roll back if it panics. And yeah, because Snapd expects some defaults in your configuration, it will actually be necessary that you pick that list of config options to make the system work. So the gadget snap, again, as I said before, is defining all that stuff that's written there. I don't need to repeat that all. But imagine you want to build a Kodi appliance. I'm using Kodi on UbuntuCore on my TV at home since a few years already. And I have a Kodi snap running on that. To build the appliance, Kodi needs a lot of extra interfaces that need to be connected. So I'm having a very long gadget YAML where I have all the connections predefined. Well, that means I can just flash the image to the SD card, dump it into the Raspberry Pi, wait until it's booted, which can take quite a bit. It will be auto-connected and everything, and Kodi will just come up on screen, and I can turn on my first channel if I want to watch TV. To build your Ubuntu Core image, you need to assemble it from all these different snaps. So we have a tool for that. It's called Ubuntu Image. I was actually planning to show on stage how that works, but the time is too short for that today. There will be a workshop later in the week where we look into attaching an environmental sensor to a Raspberry Pi on Ubuntu Core, and there you will see Ubuntu Image in action. Come by if you want to. Yeah, Ubuntu Image is a snap, so you can just snap install Ubuntu Image, hand it over the model assertion, which is a little JSON file that actually tells who owns which snap, who owns this device, and so on. As you can read, there is detailed documentation that will be more in detail than I am here. So if you want to package your application for Ubuntu Core, it needs to be a snap. Ubuntu Core doesn't allow anything else. You can't run deps on it. You can run deps on it if you install LXD and start a container, then you have a standard Ubuntu environment, as you know it, with all the deps and everything that you know. But to run actual applications on your Ubuntu Core, you will want them to be snaps. And there's a ton of plugins that help you in Snapcraft to actually make everything work. So everything to build a snap can be done within a single file. You just need that one Snapcraft YAML that has all these bits and pieces and information in it to tell Snapcraft how to pull your sources, how to apply your patches if you want patches on top, how to actually deliver it in the snap later. I'm not sure if the Snapcraft tool command still works. Sergio does it? Where's Sergio? No? Oh. So we used to have a beautiful little tour in Snapcraft that's not there anymore that would guide you through how to build a snap. But well, come to Snapcraft.io and ask a question, and I'm sure Danny will answer you. And if she answers, just imagine these beautiful dinosaurs on her dress. So yeah, if you want to get involved, if you want to get help or anything, Snapcraft.io is for you. There's forum Snapcraft.io for asking questions. On the tutorials Ubuntu.com page, there are various tutorials for building snaps. And well, there's the there's the IRC Snappy channel on Libera. So this is a bit of an old slide, I guess. And the Rocket chat is also gone. So yeah, come by in Snappy on Libera or in Snapcraft on Libera if you want to chat over IRC. You can also ask questions through Ask Ubuntu indeed, and on forum ubuntu.com, forum Snapcraft.io. And that's it.
Thank you, Oliver Grawert. We have 4 minutes, so if you'd like to ask a question, please raise your hand. Raise your hands in advance. Please try and keep the questions as short and clear as possible so that we can have as many of them as we can. And please stand up when you're asking a question. That helps too.
Oh, the mic's on. I have 2 questions real quick. The first one is, from an architecture perspective, I'm just curious, is there any reason why the feature set of Snap couldn't be implemented on top of Debian packaging or some other underlying simpler packaging system? My second question is, does Snap model ABI? And if so, how?
Which snaps are built from Debian packages. So it utilizes Debian. And indeed, you could use Ubuntu Server to run a snap on top. It's not on. Hey? Ah, better. Snaps use Debian packages, even though we do have snaps like the wonderful Telegram desktop snap is one of my favorite examples. It's like a little arch system because it builds every dependency it has from source. But you usually wouldn't do that, and you utilize Debian packages to build your snaps. And you put stuff from Debian packages inside your snaps. So Debian packages and snaps are very closely tied together in either case. What was the second part about the ABI?
I was wondering about ABI in terms of like gadget level and kernel level. Is the ABI of a given package or snap modeled in some way that I can verify that my ABI doesn't break if I upgrade my compiler or something like that?
Well, if you build your kernel snap, it has to contain everything. You have to have all the modules in it. You have to have all the init RD bits in it. It has to be all in that one snap. So you wouldn't really interface with the ABI at the moment. I know we are working on the ability to sideload other modules from another snap, or to ship firmware from another snap, but that's not there yet. And I'm sure our architects will design it in a way that your ABI doesn't break.
Thank you.
About the kernel patches.
Yeah.
At the moment, they're very hard to find. The only place I've found them is via commits on the Launchpad for repository for the Ubuntu kernel, and I have to pull them out individually. So is there a chance we can get those published as individual patches as a required set in a public location that is easily accessible rather than having to wait until it's upstream?
Well, there is a GitLab repository upstream
yes,
with these kernel
old.
patches, but it stopped, or JJ stopped pushing them for newer versions. And I would like to see that going on, because there was always the assumption it will be upstreamed and upstream will accept it, and then that was delayed and delayed and delayed. But I think at that point he stopped pushing them upstream to GitLab.
Yeah, I think.
But I will ask the kernel team and the security team to actually probably update that again.
Yeah, I think the patches on GitLab are for 4.4 at the latest. So, yeah, matching your slide.
Well, there is a forum thread where there are a few 5.1 and 5.4 patch sets as well from community members that provide them through GitHub.
Probably me.
Not you, no. But you were in that discussion. I remember that. More questions?
We have time. Yeah, we have 30 seconds left for a really short question. I think there's one there at the front.
Two.
Yes, thank you very much for this nice introduction in Snap. Now, we all have learned a little bit about Snap, and many of us here probably are doing on having application projects, free software application projects, and would like to snap them or want to help on Snap Crafters. And therefore, I've organized on this conference a Snap tutorial series of 5 workshops where you can interactively learn snapping. And I will do an introduction panel today in Carmin 3 on 14:30. There we will talk somewhat more about Snap, a little bit like in Indaba. And then after that, after the break, Snapping Like Healthworth with Dani and Heather as the introduction, and during the rest of the days, many more workshops. And so you will all get great snappers, and so we will get a lot of snaps in the Snap Store, and installing applications will just work.
Okay, thank you.